Hey everyone, welcome to another session at the Reactors. My name is Rav, I'm the Program Manager at Reactor London. Before we get into the session, please take a moment to read our Code of Conduct. We're all here to learn, so please be respectful, please be kind, and please be kind and considerate of other people's opinions. The chat will be open throughout, and we do encourage you all to participate. We're back again with another episode of the series Game of Learners. And this episode is all about connecting your application to Azure Storage. With that, I'm now going to bring up Alvaro and Paul, who would lead the session. Hi, both.
Hey there.
Hey, everyone.
So let me get started here. My name is Alvaro, as she just said, and I'm cloud advocate at Microsoft Azure, and Paul is my manager. So please behave in the chat with the questions. He will be moderating today's session, and for sure, feel free to ask any question you have, and we try to answer as appropriate. So the session for today is called Store Application Data with Azure Blob Storage. And you can follow it online by going to this URL and follow the Learn module. And as I said, you can say hi, ask questions, and you can, of course, interact in the community. So in the last session on Tuesday, we saw a lot of introductory material about Azure Storage and Blob Storage and different options, but it was all a bit theoretical. In this session, we are trying to see how to build an application that connects to Azure Storage. So prerequisites for this session are none, so that's pretty cool. It's very introductory material as well. And the objectives that we have is that you can learn to organize your data with Azure Blob Storage. You can create storage resources to hold blobs. You can store and retrieve data from Azure Blob Storage. And in the agenda, we'll do an introduction to Blob Storage. We'll discuss what are blobs. We'll do a bit of recap from last session. Then we design a storage organization strategy and have a couple of exercises where we get our hands dirty with code. The first one is to create Azure storage resources. Then we configure and initialize a client library. And then we work getting blob references and working with uploads and downloads from our code. And finally, we have a summary and knowledge check. So let's get started. Like, what is blob storage? Blobs give you object storage in the cloud and an API that lets you build apps to access the data. And as usual, with Learn module, we have a use case that we try to follow. So you can attach the information that you're learning to some sort of real world example. And it's not just theories in the air, let's say. So in this case, imagine that you are working for an augmented reality gaming company, and your game runs on every mobile platform. You want to add a new feature to let users record video clips of their gameplay and upload the clips to your servers. And users will be able to watch clips directly in the game or through your website. And you plan to log every upload and viewing for using analytics and for traceability. But let's just stop here for a second. Imagine you will have to build all this on your own without the help from the cloud. Like already logging and monitoring every upload and every view of your video. That thing alone will require a team of engineers developing only that feature of the application. If you want to support a website and be able to watch directly from there, again, all things that if you want to have blobs with all this data and these blobs archived somewhere, you need to design the storage, you need to plan on disk, network usage, security policies, all those things. But what we always need to understand from the cloud is that as developers, we shouldn't worry about those things, because securing files on a file system and on a network should be a solved problem. And that is what Azure and Azure Blob Storage is doing for us. So I think it's pretty cool. But let's keep going with the example. So you need a storage solution that can handle thousands of simultaneous uploads, massive amount of video data, and constantly growing log files. You also need to add the viewing functionality to all your mobile apps and your website. So you want API access from multiple platforms and languages. Here you see how Azure Blob Storage could be appropriate for this app. Again, just imagine implementing a whole REST API that cannot only serve the files, it can do it in a performant way. So all these tasks that let's say when you discuss with your CTO, with your technical lead, and you're seeing many options on the table, consider that moving to the cloud and having a solution like Azure and Azure Blob Storage is saving you from actually having to code all those things. And as we know, with code, it comes bugs, and we don't want bugs. So no code, no bugs. So this is pretty cool already, sounding from the start. So what are blobs? We saw about a bit of this in the previous session last Tuesday, but let's recap. Blobs are files for the cloud. Applications work with blobs in much the same way as they work with files on a disk, reading and writing data. However, unlike a local file, you can reach blobs from anywhere with an internet connection. So again, when you're using blobs from Azure Blob Storage, you automatically get this capacity that your files can be accessed from anywhere. Azure Blob Storage is unstructured, meaning that there are no restrictions on the kind of data it can hold. Remember from last session as well, when you work with a more traditional database like MySQL, you are restricted to certain table and shape of your data. That's not the case for blobs. For example, a blob can hold a PDF document, a JPEG image, JSON file, video content, and more. And blobs aren't limited to common file formats. A blob could contain gigabytes of binary data streamed from a scientific instrument, an encrypted message from another application, or data in a custom format for an app you are developing. Again, you are not restricted even to the file formats I just mentioned, like PDF, JPEG, JSON, and MP4 or whatever, because for blobs, it's just any type of data that you can imagine stored on the file system. This can work also in blob storage. But every time there is a but and a trade-offs. Whenever you are designing data applications or any type of software, you know there are trade-offs. And in the case of blobs, they aren't efficient for structured data that needs to be queried frequently. Here, if you have a list of patients in a hospital, or payroll information, or your users on your website, you want to have structured data for that. Azure, for those cases, has from Azure SQL to Cosmos and other solutions that are easily to work with that type of data. Then blobs, they have higher latency than memory and local disks, and don't have the indexing features that make database efficient and running queries. Again, if you have all type of data in a blob and in a blob container, it's hard for a database to know how to optimize searching and querying that data. However, blobs are frequently used in combination with databases to store non-queryable data. For example, an app with a database of user profile could store profile pictures in blobs. And this is a pretty cool use case because sometimes when we start using databases, we get fixated to the database. And then let's say we start putting images on a database, but a database, while it will work, is not optimized for that. And blobs are specifically optimized for holding this type of data. Same when you work, let's say, with queues. Queues are very optimal for distributing messages in a network, but very small messages. So you don't want to be sending megabytes of images, let's say, in a queue. It's better to send a reference to a blob, and then your application can fetch a message from the queue, gets the ID of the blob, and fetch the blob themselves. And you don't waste all this data of the blob going to the queue sending it on the network, you get it on the other side. No, you just send, let's say, a link, and your application retrieves that. So yeah, when you design an application, we have to be smart about how we start connecting all these databases and features from Azure to get the best from our money, basically. And each user record in the database will include the name or URL of the blob, container, the user picture, as I just explained. So yeah, you can mix both. And finally, blobs are used for data storage in many ways across all kinds of applications and architectures. Applications that need to transmit large amount of data using a messaging system that only supports MAU messages, these apps can store data in blobs and send the blob URLs in messages, what I just explained. Blob storage can be used like a file system for storing and sharing documents and other personal data. Static websites like images can be stored, static web assets like images can be stored in blobs and made available for public download as if they were files on a web server. Here is the same, like you imagine you're trying to make, let's say, an Instagram clone. You don't need to your database to hold all this information, and it's much more lightweight to have very tight records that hold metadata about an upload, about the user social graph, and so on, and just a link to the image. And even that link with the proper authentication authorization can be even what displays the image already on the browser, like it was a static and a static asset, let's say. And many Azure components use blobs behind the scenes. For example, Azure Cloud Shell stores your files and configuration in blobs, and Azure Virtual Machine use blobs for hard disk storage. What are we trying to say here? Azure Blob Storage is good enough, let's say, for Azure-owned virtual machines or Azure Cloud Shell. So you can imagine that it is already quite battle-tested. So about concept regarding storage account, containers, and metadata. In blob storage, every blob lives inside a blob container. You can store an unlimited number of blobs in a container and an unlimited number of containers in a storage account. Containers are flat. They can only store blobs, not other containers. So you cannot have hierarchies of containers. You just have your storage account, many containers, but then inside you only have blobs. Blobs and containers support metadata in the form of name value string pairs. Your application can use metadata for anything you like a human readable description of a blob contents to be displayed by the app, a string that your app uses to determine how to process the blob's data, and so on. For instance, you can tag like the expected resolution that your image should be resized to. Let's say you're working again in an Instagram clone, an image sharing website. You know that the file should support, I don't know, iPhone users, Android, the web, and you can use those tags and in a smart way decide how you consume the blobs on other parts of your application. You go into the metadata and you know what to do with this particular blob. An important detail is that blob storage do not provide any mechanism for searching or sorting blobs by metadata. For information about using Azure Cognitive Search, at the end of the module, you will see links to that. But yeah, if you want to get into the metadata and do queries there are other services that will help you with that task. So how does it work? How does the Blob Storage API and the client libraries work? The Blob Storage API is REST-based and supported by client libraries in many popular languages. So let's see about a storage organization strategy. When designing an app that needs to store data, it's important to think about how the app is going to organize data across storage account, containers, and blobs. So you can have one account to store and organize all your blobs, but it's better or it's advised that you use more than one account as necessary to logically separate cost and control access to data. For instance, you can have a storage account that is prepped for high performance and high activity in your site. You have the best SSD storage behind and all that stuff. But you don't want that your developers, when they are creating containers for testing blobs and testing your application and doing a proof of concept, let's say, you don't want them to be spending so much money in the top tier of our storage accounts. So to avoid all this kind of problem that can happen from an administration point of view, you can have many storage accounts with different policies and checks and so on. So you are sure that, let's say, on the cost side, you are safe. Also, when somebody wants to audit your data, and for instance, who has access to the data, your main production storage account can only let a few required administrator users log in there, but nobody else on your organization could get access to that data. And this will help with compliance and different scenarios. So again, while you could have all your data in one storage account, it is better or advised that for your production needs, you start separating from development to stage to production and other different scenarios. So containers and blobs. So the nature of your application and the data stored is what should drive your strategy for naming and organizing containers and blobs. Applications that use blobs as part of the storage scheme that includes a database often don't need to rely heavily on organization, naming, or metadata to indicate anything about their data. So let's digest this. You are using your traditional database and blobs both together. So in that sense, most of the information, metadata and whatnot about your application, about what the data does, will live in the database. And you only leave or use blob storage to keep the actual, let's say, image. But who uploaded the image, at what time, if the image needs to be resized, if it needs to be distributed to the user followers, or whatever, all those things live on the, let's say, traditional database, and you only have blob storage for the heavyweight data like your images. Such applications commonly use identifiers like GUIDs as blob names and reference these identifiers in database records. The application uses the database to determine where blobs are stored and the kind of data they contain. Again, separation of concerns, and you let every tool, let's say, at your disposal, every tool that Azure offers, you let them do what they do best, let's say. And that is something very important, because usually when we are early in our software developer careers, we get, let's say, enamored of a tool. We learned about, I don't know, Azure SQL, and then start learning all the cool things that you can do with Azure SQL, and then everything is built on Azure SQL. Well, that's okay, but maybe there are options to be more optimal from a cost perspective, from an architectural perspective, from improvement that could be done in the future to your application. When you start doing this separation of concern, like what is explained here, your strategy regarding blobs and how you scale that side of your app will not affect the traditional database side of your app. And vice versa, if you need to change your database schema and so on, you only know that you need to keep track of the blob GUID to connect both. But other applications may use Azure Blob Storage more like a personal file system, where a container and blob names are used to indicate meaning and structure. Blob names in these kinds of applications will often look like traditional file names and include file name extensions like JPEG to indicate what type of data they contain. And here, we discussed this last Tuesday, you can use virtual directories to organize blobs, and you will frequently use metadata to store information about blobs and containers. But there are a few things that you need to consider when deciding how to organize and store blobs and containers. The blob names and the container names must follow a set of rules, like including the length limitation and character restrictions. And in the further reading section of the module, you can find more about that. But also remember that, as it says in this previous slide, it's virtual directories. So when you start putting like forward slashes to build sort of a tree structure for your blobs, like you will normally do on a file system, like on Windows Explorer, that is not the same. You are not having directories. These are virtual directories, mostly from an organization perspective, so you can see the structure of your data, but they don't work like directories. So that is something to keep into account. Sorry. So public access and containers as security boundaries. By default, all blobs require authentication to access. However, you can configure individual containers to allow public downloading of their blobs without authentication. Public downloading supports many use cases, such as hosting static website assets and sharing files. This works because downloading a blob contents works the same way as reading any other kind of data over the web. You just point a browser or anything that can make a GET request at the blob URL. Again, Blob Storage works with a GET or a REST API, and if you can point to the URL of the blob, you can access the blob. That is pretty cool, but again, security concerns, right? And that's why this is something that is pretty cool from a philosophy perspective on Azure, is that, first point, by default, all blobs require authentication to access. And that is pretty cool because we know that sometimes when it comes to security, it's better, let's say, safe than sorry, because we can sleep on our management of data, and then suddenly all of our data is public. No, actually say no. All of your data requires authentication. You have to go somewhere and click or run commands on the command line to actually allow that your data can be accessed without any authentication. So again, here is a pretty cool feature that also is always enabling your application. This is not limiting your application, it's enabling it to do more, because at the end of the day, you get that get URL where you can access to the blob contents. So enabling public access is important for scalability, because data download directly from Blob Storage doesn't generate any traffic in your server-side application. What does it mean? Like, I read that and saying, like, what are they talking about here? You have your application in one side running, and you have Blob Storage. If your application will be delivering to the browser, let's say, or to the mobile application, it will be delivering the images, your application will be incurring network traffic costs that for an application are probably more expensive than for your Blob Storage account. So because your application is sending links to do GET requests to the Blob Storage account, in that sense, your application is not wasting that type of network traffic. It goes from your customers, let's say, directly to Blob Storage. So even if you don't immediately take advantage of public access, or if you use a database to control data access via your application, you need to plan on using separate containers for the data you want to be publicly available. And yeah, again, because on Blob Storage, you can be very fine-grained on where you enable public access. It's better if you have containers that are specifically public and not everything is public, because that will lead to chaos and to security leaks. So be very mindful about the usage of these security settings. But big caution, red alert. Anyone who knows their storage URLs can download blobs in a container configured for public access without any kind of authentication or auditing. Never put a blob data in a public container that you don't intend to share publicly. Again, I read it twice because this is very important. Anyone who knows their storage URLs can download blobs in a container configured for public access without any kind of authentication or auditing. Never put blob data in public container that you don't intend to share publicly. I don't think I could do it a third time, but I guess you get the point. Be very mindful about how you configure access to your data. That is the morale here. Be very mindful about how you configure access to your data. So in addition to public access, Azure has shared access signature feature that allows fine-grained permission control on containers. Precision access control enables scenarios that further improve scalability, so it's helpful to think about containers as security boundaries in general. And when we talk about shared access signature, in Azure, you can create these shared access keys that we already saw in the previous session on Tuesday, where you can decide for how long a specific customer, let's say I go to my app in my phone, this specific phone can access that blob container for the next 15 minutes to download an email attachment, to download an image, whatever it is that you have stored on Blob Storage. And that for me is pretty cool because you imagine if you had to implement all this on your own versus literally you can do it either from a programming side in like in your application, or you can do it on manually on portal. You go there, literally click and set, I want a shared access key for this resource with this permission, with this time to leave, blah, 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 blah. And there you have it. Use this link to access this URL. In 15 minutes, it's gone, it's dead. You don't need to care about the link anymore because Azure will take care of that for you. Just implementing that, literally in many companies, that is an interview question. How will you implement that thing? And Azure is doing it for you. So maybe say I use Azure, and then you have your interview solved, hopefully. Anyway, so blob name prefixes virtual directory. So technically containers are flat and don't support any kind of nesting or hierarchy. But if you give your blobs hierarchical names that look like file path, such as finance /budget /2017 /Q1.xls, the API listing operation can filter results to specific prefixes. And this enables you to navigate the list as if it was a hierarchical system of files and folders. This is what I mentioned earlier, that while containers only allow for flat data, you can still use this hierarchical type of thing, like directories or file path. And the cool thing is the API you can filter by prefix. That is pretty cool. You can use this list as a mini query system for your blogs, which I think is already gives you a lot of flexibility. So this feature is often called virtual directories because some tools and client libraries use it to visualize and navigate blob storage as if it was a file system. Each folder navigation triggers a separate call to list the blobs in that folder. Using names that are like file names for blobs is a common technique for organizing and navigating complex blob data. Then regarding blobs, there are types, and depending on your use case is which one you want to choose. There are block blobs, which are composed of blocks of different sizes that can be uploaded independently and in parallel. Writing to a blob involves uploading data to blocks and committing them to the blob. Append blobs are specialized block blobs that support only appending new data, not updating or deleting existing data, but they are very efficient at it. Append blobs are great for scenarios like storing logs or writing stream data. Page blobs are designed for scenarios that involve random access, reads, and write. Page blobs are used to store the virtual hard disks, files used by virtual machines on Azure, but they are great for any scenario that involves random access. Here, what you need to take from these slides is that data, as we explained in the last session as well, has different access patterns, whether it's reading or writing access patterns. And depending on that is how you want to store how do you want to store the data. Imagine, for instance, like this is like algorithm and data structures 101, let's say. If every time you went to the supermarket, instead of having a queue for paying, everybody will be standing around the cashier, and the cashier will need to remember or do some sort of choosing who goes next. That is a very bad access pattern for that very specific use case. For that specific use case, you use a queue. So in this case, if you want to append data because you are receiving a lot of logs for let's say, doing analytics later, then you just choose an append blob. Could you do the same with the other blobs? Probably, but it's not optimized for that type of access. And in the cloud and everywhere, you want to be very mindful of the resources used, both for your for the cost usage and also for today that we want to build green applications. If you are conscious about all this stuff, you will be optimizing the resource usage of your app in the cloud. So block blobs are the best choice for most scenarios that don't specifically call for append or page blobs. Their block-based structure supports very fast uploads and downloads and efficient access to individual pieces of a blob. The process of managing and committing blocks is automatically handled by most client libraries, and some will also handle parallel uploads and downloads to maximize performance. So let's do a quick knowledge check. You can answer in the chat, of course. Suppose you need to store profile and order information about your customers. You need to query the data to answer questions like, who are my top 100 customers and how many customers live in a given geographic region? True or false? Blob storage is a good choice for this data. What do you think? True or false? You have complex data about your customer. You need to run a lot of queries, like who are my top 100 customers, or how many customers live in a given geographic region. Will you use blob storage for this? The answer is false. For this type of scenarios, you probably want to use a traditional database. And here is something that I find cool about this type of learning material, is that you should or be wary of anybody that presents you technology without showing you trade-offs. Any technology will have trade-offs. And in this case, we can see blob storage is great, but for some type of application is not the best choice. And as this Learn module is also trying to teach you, which I think is pretty cool. Blobs provide unstructured data storage. What does unstructured mean? Blobs can't be organized or named. There are no restrictions on the type of data you can store in blobs. And C, blobs can contain structured data like JSON or XML. So what do you think? Unstructured in unstructured data storage means that blobs can't be organized or named, that there are no restrictions on the type of data that you can store in blobs, or that blobs can contain structured data like JSON or XML. And the correct answer is B. For sure, they can be organized and named, which are so virtual directories. And for a blob, if data is JSON, XML, an image, or any random thing that you get in a file, they can be all stored in blobs. So now we are going to move to exercises. So let's switch to the browser. And hi, team from Kenya, James from London. Nice to meet you. In my case, I'm doing this module from Zurich, Switzerland. So it's pretty cool. There are people from everywhere. So let's go to, or let's review the first exercise here. Of course, you can follow them if you want with the Azure Cloud Shell that is there. I will mostly, for the sake of time, go through what you need to do, and you can replicate at home. So once you have like an idea of the resources that your account needs, is when you need to start planning how you will use these Azure resources to support your application. So storage account. To create a storage account, this is let me know if I should make the font bigger in the chat. And there is somebody from Seattle. Yes, Invictus. The particularity of Seattle and Zurich is we are on the same latitude, so very similar weather and times and so on. Anyway, it's pretty dark here. That's what I'm trying to say, despite being only 5 p.m., 5:30. Yeah, so storage accounts. Storage account creation is an administrative management activity that takes place before deploying and running your app. So you will either go to an environment script or a storage management template or manually, and you will first create your storage account. And very important, let me find my mouse. You should be very careful with who can create storage accounts. If possible, almost nobody in your organization should have that power, because they can also remove you as an administrator. So this is something that your company needs to be very clear about that. But let's go to containers. So first we have the storage account, then we have containers, right? Unlike storage account creation, a container creation is lightweight activity that makes sense to perform from within an application. It's not uncommon for apps to create and delete containers as part of their work. So why is this important? Because who remembers, if you remember, raise your hand in the chat or send a note. When working in the past, before the cloud, when I say before the cloud, you can see why I have all this gray hair in my beard. When you had to go to your sysadmin and ask them, can you create a table for blah, blah, blah on, let's say, MySQL? Can you give me access to, I don't know what, because now I have a new feature on the application and I need to upload images to this file system, or I don't know. Like, you had to go through a lot of hoops to be able to do that. But with Azure, with the cloud and containers, this is actually pretty simple, because once your application is logged into your storage account, it can create containers. And of course, it can create blobs, but you don't need to be asking for permission and so on. And as it says here, it's very lightweight. So you just do it from the application directly. And this is the goal of the exercise, is to complete an application that will let you upload files by drag and drop, and then you can do calls to the Blob Storage API, like here, and list the files that you have uploaded to the app. So the application will be like a shared folder that accepts uploads and make them available for download. It's not using a database for organizing blobs. Instead, it sanitizes the names of uploaded files and uses them as blob names directly. This is also very important. Anytime you work with user data, you have to sanitize it. It doesn't matter who is uploading the data, okay? You sanitize the data. Even, this is not a problem, let's say, for blob storage. I assume. I could think it a bit more, but what I'm trying to say is like, you can even craft security attacks with a name of a file, okay? And that's why, as it says, sanitize everything. In this case, the name of the uploaded files, because never, this is sad to say, but on the internet, on the other side, there could be a dog in the computer for all we know. So be careful. And probably dogs, they behave way more than humans in many cases. Anyway, the code you start with compiles and run yet, and for yeah, after you complete the code, you will be able to deploy this application to the app service and test it. But the first thing you need to do is to set up your storage account. In the previous session, I showed you how this could be done. We have a question from Shane. Does the $ prefix serve any purpose in storage or for file share? I see this sometimes created for single static websites. I honestly don't know about that example. I really don't know what the $ prefix does. I don't know if it's more a convention than actually something that the application or that Blob Storage is handling, let's say. So anyway, in the previous session, we saw how to create this from Portal, but you can also do it from the Cloud Shell here. You can run this code, and at the end, you need to provide the name of your storage account. So let's call it Game of Learners, November 22. Hopefully that's not taken. And once you run this command, it will create an storage account. So in the app we are going to build, you are going to use only a single container. Of course, you can create a container from the CLI, but you can also create it directly from the application. So next. So the typical workflow for applications that use Blob Storage is like this. You will retrieve the configuration. So when your application starts, it loads the configuration, and there you get the storage account. Typically, it's a storage account connection string. Then you initialize the client. To initialize the Azure Storage Client Library, you will use the connection string. And this will create the object that the app will use to work with the Blob Storage API. We will soon see this in the code. And then once you have this API client on your application, you will operate on containers and blobs and make all type of API calls in the library. Then, how do you get the connection string on your application? Before you're running your application, you need the connection string for the storage account you use. You can use any Azure management interface to get it, including Azure Portal, Azure CLI, or PowerShell. So you will go to your Azure Portal storage account, and there you can have 2 connection strings. You will use one of them. So when you set up the web app to run your code near the end of this module, you will use the Azure CLI to get the connection string for the storage account you created earlier. Yeah. This is what I'm trying to say. Like storage accounts, the connection string, they include your account key. You need to keep this secret and secure. Like, do not share the string with anybody. To make this easier, in this exercise, you store the connection string in app service, and the app service app settings is a way to securely store the secret for your app. And there, like, your application will connect and fetch the keys directly from app service. Here, let's look at this specific sentence. Do not place storage account keys in code or in unprotected configuration files. As I said earlier, the whole of your account will be available to anybody with this connection string. If you leak it, people will probably abuse it, uploading all kinds of things into your storage account. So be very careful about that. So how does it work to work with the SDK for Azure Storage? So first, in this example, as you can probably already saw, but we are going to use .NET. And we work by initializing a blob service client by giving the connection string. And then we get the blob client. So let's see. Is blob service client is a blob service client class. And from the config, we provide the connection string that we obtain from Portal or from different locations as discussed before. Then this object that we just created, the blob service client, we ask the class to get us a blob container client. And we provide the name for the container that we want to create. And we use that container client. Then another thing that is important is that when we need to have the container, we call this thing that I said earlier, create if not exists async. So Invictus is saying don't put it in a cloud on node where you keep yours. Yeah, don't write your storage account under your keyboard, right? So the cool thing about this create if not exist async on the container client is that your application can always call that. You don't need to care if the container is there or not. The application will take care of creating it. If it's not there or if it's there, nothing will happen. So you have an application that is self-contained, very tight. All the code that you need is there. It simplifies a lot deployments and so on, because you are not worrying if I deploy this app now, will be the container created there, or I can just run it. Yeah, with this pattern, you can just run it. So to start working on the app, you will clone the application directly from the Microsoft Docs from GitHub, and you end up with this thing here. You can find the example in Java and in .NET. We are going to use .NET. So let's keep going. So in the editor, we can open the files controller. So it's in controllers, files controller. Here, you can see that we are implementing 3 actions: index, and upload, and download. So, sorry for that. So the index is how the application will return the index page. Upload will handle all the upload of images, and and download sends the image to the browser. So all of this is going to models and calling this or implementing this API. This API is the API that we want to fill in for sure. As you can see, none of this is implemented, and that's the part that you should implement by following the tutorial. But before going, what you want to do is, once you have this code clone, go into the folder of the code you just downloaded, and there you will run .NET, which is the command line tool for .NET, and you make it add the package Azure Storage Blobs, and then restore, which will fetch the package and make sure everything is ready for your application. So that is for initializing the client library. So how do we, sorry, how do we initialize the blob storage class? So at the moment, you can see that we don't have any reference to the client libraries that we just downloaded. So basically what you need to do here is to copy this code here and put it as a part of the using statement for your class. And then in the blob storage as well, in the same class, we will implement the initialize method, where let's go there and let's paste it here. What is going on here? As I discussed earlier, you know that we have the blob service client that retrieved from the storage config the connection string, and it gave us a client class. This class then retrieves the container based on a name. So far, as we said earlier, none of these things have done a call to the API. But here is where we say create if not exist async. And with that pattern, we are sure that the container is ready for the application to run. Let's keep going. So to list blobs that are present in a container, we will use the blob container client's get blob async method. Behind the scenes, the method is doing one or many HTTP request calls to Azure to list the blobs in a container. And because the method is asynchronous, we have to use await to get the results as they are received from the HTTP calls to Azure. So the standard pattern is as follows here in the example. We get the blobs asyncs, and then we can, for each any of these blobs that we receive from the container client. But keep in mind, because for me, it was a bit confusing at the beginning when I was learning to work with this, is that you are working with the container client, that you have the blob service, you connect to the blob service, then you get a container client, and then you work with the container client. So keep in mind this class structure that the SDK offers. So now let's go to blob storage, get names, this one. Let's try to implement this thing here. So first we have a list where we will keep all the names that we want to return to the browser with a list of blobs. And we get the blob service client, we get the container client, and then we get all the blobs async. We add them in this for each to the list we created first, and then we return those names to the browser. You can see you end up with a pretty clean code, and code that is very idiomatic as .NET code, let's say, with this whole API in the SDK. So when this whatever is returned from this method is processed by the controller will make sure that all the methods the files are transformed as URLs and so on. Then uploads and downloads. Now, this is what I was trying to say before about the structure of the SDK. Now we are working with the blob client. Before we were working with the blob container client, but now we need to the container client say, give me a blob client. And then because we are working with blobs directly, we use the blob client. So again, the storage client class, then we have the blob container. Remember, storage, containers, and blobs. So storage client, blob container client, and blob client. That's the structure that we need to follow to use all this stuff. So another cool thing from the API is that because all this data movement that we do requires network time, is all done asynchronous. So whenever you can in your application, don't block your application while you retrieve data from the network. Actually do async operations, and you can imagine you have 3 people in your house, and you tell them, can you bring me a plate from the kitchen, bread from I don't know where, and the table. And you don't want to wait for one to come with the plate, from the other to come with the bread, and from the other to come with the cloth for the table. All these 3 persons can go asynchronously, come back with the result, and then you prepare the table based on that. When you work with asynchronous data, think on that pattern. Think how you can optimize the access and retrieval of data, and not block your application for, I don't know, 5 minutes, because there is no need for that when everything can be done in parallel. And another thing that is recommended is to using streams, because streams can pipe things from one end on the network to another, and you are not, let's say, loading the whole file in memory. Imagine if you have a file that is gigabytes big, and you load everything in memory in your app, it will consume a lot of resources, and then you offload that to the network. If you have a stream, you can pipe things from stream to stream, and you are not wasting resources. So how do you create new blobs? As I said earlier, you get your container client. You ask the container client to give you a blob client, and then there is your blob client object. And with that object, you say upload async the stream of the file, and you will get a response if it was uploaded or not, and so on. So for the exercise, now we're going to go to Blob Storage, to this class, and implement the code for save. Let's copy this. Let's search save. And let's put the code there. So what's going on here? As I said earlier, class structure in the SDK. Blob service client gives you the client class. From this Blob service client class, you ask for a container client. You get the container client object. And the container client, you say, give me the blob, because again, now we are working with the files themselves. And this blob is the one that does the upload. So that's that. And as I said earlier, yeah, because we are using streams, this is a bit more efficient. And to implement download will be similar, which is in the load method here. Again, Blob service client. From Blob service client, we get a container client. And finally, with the container client, we get the Blob client. And we open read async. So that's how we load stuff from what's coming from the browser. Then you want to run the code on Azure. For that, you need to create an application service and configure it so the application settings for your storage account, connection, string are there. So by running this command, Azure Storage Account Show Connection String, you can get the storage account string. For your app name, for sure, this needs to be globally unique. So you will choose a unique name. Let me see chat. So Siegfried is asking about the difference between the virtual directories and what you see in Portal with Azure files. I honestly will have to follow up on you after the session because right now I don't have the answer. Maybe somebody else in the moderation team knows, but I don't have the answer. So to create your application, you will run this command, Azure CLI application server plan create. You will give it a name, you give it a resource group for SKU select free and location central US. Then you create the web app. Again, your unique name, unique application name. Then you have the plan that you're going to use and the resource group. Then your connection string, you will obtain it by running this command. And this is doing like a subshell that is executing the command and storing the value returned by that command into the connection string. And this is something quite important. Like anytime you work with connection strings, try to use commands that don't output the connection string to log files, to the command line, anywhere. Because a connection string that got logged somewhere, you don't know when or how that could be accessed by somebody that then can get access to your application. And then finally, you set up the application settings for the config, so your web app can have the connection string stored there and access directly from the app settings, and you don't need to touch anything this in your code and so on. Then finally, once you want to push the application, you can do .NET publish to this folder. You can zip it, and then with Azure CLI, you can send that to Azure and run it, and you should see something like what you see here. And also, if you want to test that this works also from the command line, you can list your blobs locally. And if you want to make sure that what you followed in the exercise is correct or contrast your code, remember that you have the non-finished version of the application, and you have the final version. In the final version, everything is implemented. So if you want to make sure, or you want to compare your what you did with the original exercise, you have all or both versions of the code there. But let's get back to the slides so we can finish the presentation. So, summary. So you discovered tips for creating a strategy to use blob storage in a web app. You learn how to use the Azure Storage SDK to list, write to and read from blobs. You created an app that accepts uploaded files from users, stores them in blob storage, and makes them available for download. You deploy the application to Azure Application Service. If you want to read more, that's the links that we will mention during the presentation. And some knowledge check is question number 3. Which of the following describes a good strategy for creating storage account and blob containers for your application? A, create both your Azure Storage account and containers before deploying your application. B, create Azure Storage account in your application as needed. Create the containers before deploying the application. Or C, create Azure Storage account before deploying your app. Create containers in your application as needed. And the option is the last one, as we say. Let the containers be created dynamically by your application, so you have way less management overhead for your app. Then, which of the following can be used to initialize the blob storage client library within an application? A, an Azure username as password. B, the Azure Storage account connection string. C, a globally unique identifier GUID that represents the application. Or D, the Azure Storage account data center and location identifiers. So the option is B, to initiate or to create or initialize a blob storage client library, you need the Azure Storage account connection string. And question number 5, What happens when you obtain a blob client reference from blob container client with the name of a blob? A new blob is created in storage. A blob client object is created locally. No network calls are made. An exception is thrown in the if the blob does not exist in storage. And D, the contents of the named blob are downloaded. And the answer is B. A blob client object is created locally. No network calls are made. And that's it for me today. We are a bit over time, so there won't be much time to discuss later. But yes, thank you everybody for being here. We have an answer from Paul. Azure Storage is best for storing large amounts of unstructured data, where Azure Files are distributed cloud-based file system. Yeah, so if I'm not mistaken, with Azure Files, you can have SMB and all these kind of file shares, which I don't is not the same use case than Blob Storage does, because scalability-wise also, and the way you share the URLs and so on, you want to you have a backup carrier as an instruction for sure. Thank you, Invictus. So with Blob Storage, you have all this fine-grained way of sharing, let's say, images for a website with all these URLs. So while in Blob Storage you have the virtual folders, that doesn't really mean that you have a directory structure like in let's say, SMB. And if you want to create, let's say, an Instagram clone, you are not going to create one of those with SMB, but you could create one with Blob Storage, because again, the folder structure is more a hierarchization of the data to make it easier to find, but not necessarily what is happening behind the scenes. You don't have any folder operation and so on. So yeah, similar on the outside, but on the inside, what you actually, all the advantages that you get are again different tools for different use cases. Again, thank you everybody for being here. And yeah, we see next week there will be more of these Game of Learners clinics. Thanks again, and bye-bye.